Alright, now what we're going to talk about is what's called the composition of functions. And when we talk about the composition of functions, what we are usually doing is plugging a function into the function, into another function. So if I am being asked to do this, the little symbol that is used is this little open circle between the f and the g. Okay, it's different than f times g of x. Okay, that means multiply. Okay, as does just the two letters touching each other, fg. Okay, but the little open circle, it's not the letter O, this does not say fog, but f of g of x. Okay, what it means is we are going to take f, and instead of replacing the x with a 1 or a 2 or a 7 or a 9, we're going to replace it with the entire function g of x. If I'm asked to take g of f of x, the first letter on the list is the one on the outside. The second one is the one that is being plugged in. F of g of x. So if here is our f of x and there's our g of x from our videos earlier on, okay, again, we know that if I want to find f of 1, then I take 2 times 1 plus 3 to get 5. Or if I want to find f of 7, I take 2 times 7 plus 3, which is 17. Okay. Or if I wanted to find, in another video I made, I said if I want to find f of t or f of p or f of something else, then I replace the x with that something else. Okay. Here, oh goodness, pretend that's an open circle. My pen is getting very fat. Okay, if that says f of g of x, we said that means f of g of x. Now we know f of x looks like 2x plus 3. But this is saying instead of the x, I'm going to replace every x with all of g of x. So I'd have 2 times the quantity 5x minus 4 plus 3. From here, we're going to distribute the 2 and then combine like terms to simplify that expression as much as we can. If it says, instead I want you to find g of f of x, that means, and if it helps you to write this step here, then please do on your paper. If you don't understand what that means, you can go straight from here over to there where my arrow was aiming. Okay, we know g of x looks like 5x minus 4. But now, every place there's an x, I'm being asked to put all of the function f, which looks like 2x plus 3. So just like above, we will distribute and then combine like terms if possible. Okay. Notice that g of f of x does not equal f of g of x. Okay, there are some sets of functions that we'll talk about later on if you're in college algebra that it doesn't matter what order we plug them in. We're going to get the same thing out over here. Okay, those have a special relationship. These do not. Okay, they might look similar. They both have a 10x, but they aren't going to be the same. If find my other page. Okay, with my h and k, just like with our h and k that we did here, we said, well, instead of an x, I had a number in there. So if instead of saying, let's find h of k of x, maybe it wants h of k of 2. Again, if it helps you to write it in a nested form like this, then please do it. But when we are doing arithmetic, understand there's a difference between what we did on this page and what we're being asked to do here. Okay. On this page, when I was asked to plug in the 2, notice I plugged the 2 into both h and k. I plugged 5 into both h and k. 1 into both functions, 0 into both functions, and then I did my arithmetic. That's not what we're being asked to do here. Here it says, I'm only putting 2 into which function? I'm only putting it into k. So I go to k, I replace the x with the 2. 4 times 2 is 8 minus 1 is 7. And now I'm going to put the 7 into h. So h of 7 looks like 3 times 7 plus 7. 21 plus 7 is 28. H of k of 2 is equal to 28. Okay. When we're doing composition of functions, we are always working our way from the inside out when we have nested operations. Okay, we started on the inside and worked our way to the outside. Okay, what that is that works from right to left on the notation, the original notation. 2 went into k, 7 came out, I put the 7 right back into h. Okay. Now this video is getting long, but I'm going to try to squeeze a couple more examples in here. Okay, so in a minute I want you to pause the video and I want you to find h of k of 0. I want you to find k of h of 3. And I want you to find h of -1. Okay, so pause the video, try one or more of these, and then when you turn it back on, I'm going to go straight to the answers. All right, on the first one, h of k of 0 means I'm going to start by only plugging the 0 into k. If I plug 0 into k, 0 minus 1 is -1. Okay, then I take that -1 and I plug it into h. -3 plus 7 is 4. H of k of 0 is equal to 4. K of h of 3, the 3 goes into h. When 3 goes into h, 9 plus 7 is 16 comes out. Then it says 16 has to go into k. 4 times 16 is 64, minus 1 is 63. H of -1, even if I accidentally go backwards, I know the -1 has to go into h, which I know from before. I get a 4 out of that. And then the 4 goes right back into h. So 12 plus 7 is 19. Okay, make sure you get a hold of me if you need to see and work through more examples of this with me.